Now let's go over to problem 2. Problem 2 is a continuation from the previous problem. Sometime later, a team of students analyzed the commuting time for the head of household in Cook County, Illinois. Well, in Cook County, Illinois, earlier, with this sample size 2,500, got the mean of 42.6 and a standard deviation of 16.7. Now, a group of students repeated this experiment, and then, well, based upon those, we have to answer these questions. 2.1. The students wish to estimate the mean commute time with 95% confidence level within 3 minutes of margin of error. Based upon the standard deviation for the previous study, which was 16.7 minutes, at least how many people should the students interview? So sample size is unknown. In the previous case, sample size was given as 2,500. Here, sample size is unknown and mean is unknown. Well, there are a lot of question marks, but you can still answer this question. By the way, let's go back to the previous problem here. Estimate the 95% confidence interval here, and let's go to conclusion. Yes. 42.6 is the best point estimate, and confidence interval you get is 41.94 to 43.25 something, and within the confidence interval the biggest error you can get is the center all the way toward the end, to the left or to the right, because of symmetry. So 42.6 minus 41.9454, 0.65 something. You're going to get the same thing the other side too. 2546 minus 42.6. Well, not surprisingly the same thing because of the symmetry. That's the maximum error. That's the margin of error you're going to get. What if your true mean is even bigger than x2 in the red region? Well, that probability is less than 5%. So within 95% of confidence level, we just disregard and just consider within the confidence interval only. So the margin of error in this case is 0.6546, so 0.65 minutes or so if we use 2,500 people as a sample size. Now here we want 3 minutes as margin of error, so we expect a lot smaller sample size this time. Can we answer that? Well, let's draw a picture first. Remember the process: outline, center, shade. Outline, center, end, and shade. Excuse me. Outline, center, end, and shade. Outline, center, end, and shade. But center, what is the center? 42.6. Actually, that's several years ago. We don't know that. New result will come. As a matter of fact, if you go down several problems based upon students' results, 48.8 minutes. So things are a little bit different. At this moment, it's unknown. x1, x2, again unknown. We only know 95% in the middle, 2.5% in the left, 2.5% in the right. And standard deviation from the previous study, so 16.7 minutes, just use that. From this, we can answer the sample size. Too many question marks, but can we still do that? Amazingly, the answer is yes. Yes, we can. The idea is, again, the z-score formula. Z equals to n minus center over standard error, isn't it? Let's expand the picture. Okay. N minus center over standard error is standard deviation 1.67 over square root of or sample size? We don't know that. Too many unknowns. We don't know what the end is, we don't know what the center is, we don't know the sample size. How do we figure this one out? But amazingly, we do know what is end minus center. We're using 3 minutes of margin of error. So that's what we are going to do here. This is 3, and consequently we can solve that equation by finding out appropriate z-score here. What do you think is the z-score here for 95% in the middle? Of course, 1.96. How about negative 1.96? Well, I set this one as positive, so positive 1.96 is better. But if you use negative 1.96, then this should be changed to negative accordingly. To me, having too many negative signs just confuse me, so I just stick to positive numbers. You see, we are talking about margin of error and number of people, all are positive, just stick to positive. So this is a general method to handle this. At first we had too many question marks, but amazingly at least 2 of them canceled each other out. Let's continue and complete this solution. Here we go. End minus center is 3 minutes, end minus center. So here we go. From here you're looking for n value. It's not too difficult. We have to find out the denominator and then flip it and, well, accordingly. Alright, how do we do that? One way to handle it is to move this denominator over denominator to the numerator. So square root of n goes over there. And then just divide away 3.0 over 16.7 by taking the reciprocal like this. And here's the computation. Square root of n is 10.91 something. Consequently, n has to be square of that, 119 something. And you see, that's the margin of error you want to do within that margin of error. So you have to be at least a little bit more accurate than that. So in this case, you always round up. So not 119.043 or not 119.0, it's 120. Of course, it's pointless to consider decimal number of people. It should be integer, but always you round up. That's how you can find out the sample size. Yeah, I explained to you the reason. Always round up. And that in the end, if you put in n equals 120, you get everything. That's a justification. But justification requires another computer exploration. Let's go back to the initial picture because this problem is tricky. Too many question marks. Center I don't know, end I don't know. All I know are 95%, 2.5%, 2.5%, that structure. But you can still figure out end minus center as 3 minutes, and that's enough to use the z-score formula. The numerator end minus center is 3, and then the denominator is SD over square root of n. You're looking for n from this equation. Algebraic solution is trickier than the other algebraic equation, so this problem is definitely harder than the other kind of problem. Okay, I admit it. I've taught this Math 1680 or equivalent for, 6-7 semesters, maybe longer. As a matter of fact, if I count the days before joining UNT Dallas really numerous times, but I've never written the sample size problem in 1000 level. In 3000 level or 2000 level I have, and heck of a lot more of course, but in 1000 level, in the exam at least, I haven't written those kind of problems. Of course, that's why I'm doing this in homework. I can cover a little bit and let you work on, but as an exam problem, I have to admit, sample size problem is kind of pushing the envelope a bit too hard side. Let's see, do I have enough time to move on to the next? Let's see, let's go. 2.2. Due to the lack of resource, the students managed to interview a simple random sample of just 27 people. Oh, we needed 120 people, but they ended up just 27 people. But they claim the normal distribution is still appropriate, still okay. Explain their reasoning. Oh, wait a minute. In the previous problem, the main idea behind normal approximation was large sample size. More precisely speaking, they are talking of the mean, of course, and simple random sample of large sample size. But in this case, no, 27 people, that's too small. But is it still okay to use the normal distribution? The answer is, in this case, yes. And the reason is that sigma value, that standard deviation can be considered as population standard deviation because it came from the previous study and it came from relatively large sample. So population is believed to be normally distributed. You have to assume that as well. And the known standard deviation, in this case you can use normal approximation too. But this one, known standard deviation, can be a little bit controversial as a matter of fact. 2,500 people, that's large enough, but some other people may say, oh, that's not large enough for population standard deviation. I want even bigger sample, which may be prohibitively big. In that case, you may have to use alternative methods using the t-distribution. But as far as the student's reasoning is concerned, the 16.7 minutes will be considered as population standard deviation because it came from the previous study several years ago and it has been accepted as, well, the status quo. Well, do you agree with that? Well, you don't have to agree, but at least that's the students' reasoning. Now, I don't have time to move on to 2.3 and 2.4, so let's stop here and let's continue in a separate video.